Welcome to another installment of Weekly Space News from Ad Astra. I'm Swapna Krishna. This week, we are going to talk about a Russian satellite that nearly slammed into a NASA satellite, how scientists discovered 3 new moons in our solar system, updates for SpaceX's Crew 8 and Starship, and the biggest sunspot of this solar cycle so far. If you're here for an Intuitive Machines update, I had one yesterday and the next one will come in a separate video soon. There's a lot to discuss from this latest press conference, so I didn't want to mix that up with this news roundup. But let's start with satellite collisions. On February 28, 2024, NASA sent out an update that the Defense Department was monitoring a possible collision between NASA's Thermosphere, Ionosphere, Mesosphere, Energetics and Dynamics mission, that's a mouthful, or timed spacecraft, and the Russian Cosmos 2221 satellite. Timed was designed to study an area of the Earth's atmosphere that we didn't know a lot about when the spacecraft launched in 2001. Earth's mesosphere and lower thermosphere and ionosphere. This is basically the boundary between what we traditionally consider Earth's atmosphere and space. It is still an operational satellite. Cosmos 2221 launched in 1992, and it's a Russian electronic and signals intelligence satellite, basically for gathering radio intelligence. It is a dead spacecraft, so basically at this point it is space junk in a decaying orbit. It slowly is falling back to Earth. Currently, it's 373 miles or around 600 kilometers above the Earth's surface. Thankfully, there was no collision. This is considered a near miss, but there likely won't be another possible collision between these 2 specific spacecraft as their orbits are moving apart from each other. But it was a really close call. According to Leo Labs, the 2 spacecraft flew within 20 meters, or about 65 feet of one another. That is way, way too close for comfort. I've talked quite a bit about the perils of space junk, and this is yet another example. Neither of these satellites have maneuvering capabilities, which means that all we could do is watch them fly by another and just hope they didn't crash. We got really lucky. Not only would that have been a devastating end to a long-running NASA atmospheric mission, but the collision would have created countless new pieces of space junk that could have threatened other spacecraft. In other news, scientists announced this week that small galaxies might have played a key role in making the universe what it is today. It has to do with the ionization of the universe, which is what made the universe transparent. The epoch of reionization occurred around 500 to 900 million years after the Big Bang, and it is when the universe became ionized and therefore see-through. Before this, during recombination, the universe was opaque. Think trying to see the starry night sky on a cloudy evening. This was what the universe was like. You couldn't see through it. But during reionization, neutral hydrogen became ionized gas. Once the epoch of reionization was complete, light was able to freely travel through the universe. This first light is what cosmic microwave background, or CMB, is. But scientists didn't know what caused the ionization of the universe. But thanks to JWST, they may have figured it out. These scientists were able to make spectroscopic observation of galaxies from the era of reionization. Remember that looking out deep into the universe is like looking back in time because of the time this light takes to reach us. As light travels through the universe, the wavelength stretches into the infrared as our universe expands. This is the idea behind redshift and why we need an incredibly sensitive, infrared-optimized observatory like JWST to see these early galaxies. These scientists specifically studied the Abell 2744 galaxy cluster to be able to make observations of these galaxies this far away. The reason this specific galaxy cluster is important is because of something called gravitational lensing. Gravitational lensing occurs when massive objects in space, like galaxy clusters, actually warp the fabric of space. What they do that's extremely valuable for scientists is bend light and sometimes actually even magnify objects that are further away. In this way, scientists can study galaxies from the very early universe that we wouldn't normally be able to see. You can see it in action here in this 2023 JWST photo of Abell 2744, also called Pandora's cluster. You see the red, flat, stretched galaxies? That is space being warped by gravitational lensing. This image was taken with exposures of 4 to 6 hours, with about 30 hours total of observation time on JWST's NIRCam or near-infrared camera. Okay, back to these early galaxies. So what did scientists uncover? Well, in an article published in the journal Nature, scientists outlined their findings that small galaxies in the early universe, similar to dwarf galaxies in our current universe, played a huge role in the reionization of the universe. These smaller galaxies way outnumbered larger galaxies during the time period, and apparently they were very efficient at producing ionizing radiation, way more than scientists predicted. That means that these small galaxies played an outsized role in the reionization of the universe. A lot of scientists have been focusing on the puzzling large early galaxies we've found thanks to JWST, and that's kind of been front and center. But these scientists have made it clear that we should also be looking at small galaxies to understand the mysteries of the early universe. In news closer to home, if you are in the mood for sunspot spotting, the largest sunspot of the current solar cycle, called AR 3590, which is currently pointed directly at our planet, unleashed 3 huge X-class solar flares. X-class flares are the most powerful solar flares, on February 21st and 22nd. Solar flares are like giant flashes of light. They're bursts of electromagnetic radiation and can specifically affect radio communication. Each of these events caused a temporary blackout in radio communications here on Earth. It's worth noting that the huge AT&T cell phone outage was not caused by space weather, it was a software issue. None of these blackouts have been devastating, but the sunspot is still pointed in our direction. If there's a coronal mass ejection, or CME, that could have much greater impact on Earth. CMEs travel much more slowly than solar flares, and they're easier to predict. They are giant expulsions of solar material, the sun's plasma and magnetic field, hurled out into space. They can wreak havoc on all kinds of communication and electrical systems, and actually cause satellites to fall back to Earth. But what CMEs also do is produce vivid aurora like the northern lights. The sun is on an 11-year solar cycle, and scientists think that we will hit solar maximum, which is the period of peak solar activity, this year. That's why we're having so much sunspot activity. Here's some great news. Remember Japan's moonlander SLIM, or Smart Lander for Investigating Moon? It went quiet on February 1st and wasn't expected to survive the lunar night. However, this week, engineers at JAXA, Japan's space agency, pinged SLIM, and it responded. We don't have a lot of updates. We know that they have been limiting communications because temperatures are so high. It can get up to 250 degrees Fahrenheit or 121 degrees Celsius during lunar day, and they want to give the equipment a chance to cool off. For more on the moon's extremes, check out my video on Intuitive Machines' heat protection for their lander. But we did get a new image from SLIM's multi-band camera of the landing site, the Scioli crater. If you recall, SLIM also ended up facing the wrong direction on the moon. In this case, it was because one of the engines failed during descent about 50 meters above the moon's surface, which resulted in horizontal movement. It ended up basically upside down. It did achieve a pinpoint landing on the moon, the first spacecraft to ever do that, just on its face. The lander will likely go quiet again, but it's been nice to have it back even for a little while. If you missed it, I posted a rundown of the Crew 8 mission in which NASA will take 3 NASA astronauts and 1 cosmonaut to the International Space Station. That launch is scheduled for this week, and if you're interested in learning more about that mission, check out the video. In some other fun news, scientists have found 3 new moons orbiting the planet of Uranus and Neptune. These are the faintest moons ever discovered using ground-based telescopes. One moon orbits Uranus and is just 5 miles or 8 kilometers in size, which means it's likely the smallest of that planet's moons. It's called S2023-U1, but it will eventually be named for a literary character like Uranus's other 27 moons, including Miranda and Ariel. It's the first new moon we found for Uranus in 20 years, and it has a 680-day orbit of the planet. The other 2 moons orbit Neptune. S2002 and 5 is about 23 kilometers or 14 miles in size and has an orbit of 9 years. It's brighter, while S2021 and 1 is fainter. That has a 27-year orbit and is about 14 kilometers or 8.5 miles in size. Both moons will also eventually be renamed for Greek sea goddesses. All 3 moons were discovered using ground-based telescope, which took 5-minute exposures over 3 to 4-hour viewing sessions across multiple nights. The scientists were able to find the moons by layering all these exposures and tracking movement in relation to host planets. In spaceflight news, this week, the FAA closed its investigation into Starship's second launch, which occurred on November 18th. Starship is SpaceX's interplanetary launch system, and it's also part of NASA's Artemis program to return humans to the surface of the moon. The HLS, or Human Landing System, to take astronauts to the moon's surface is just a modified version of Starship. Back in November, for that second test, the launch system did have a successful first stage separation, but then the super heavy booster broke apart over the Gulf of Mexico instead of splashing down. Meanwhile, the second stage was supposed to ascend into orbit, but it also broke apart on the way up. According to SpaceX, there was a leak in the aft section of the second stage vehicle when Starship began dumping its liquid oxygen. This was a planned maneuver. It wouldn't happen during a normal launch, but they wanted to carry the amount of propellant they'd need for a mission during this test. So they had to dump some of it for controlled re-entry. Well, because of the leak, the stage caught fire and the engine shut off. The first stage was lost because several of the engines also shut down during the boost back burn. They think this happened because of a blockage in the fuel lines. The FAA has approved SpaceX's reasoning for these failures and provided 17 corrective actions for SpaceX's Starship launch system. This means that the third test launch of Starship will likely happen in mid to late March from the company's launch site near Boca Chica, Texas. But it just depends on how quickly SpaceX can address these issues and obtain that new launch license from the FAA. And that is all the news I have for you this week. Thank you for tuning in. I'm Swapna Krishna, and this is Ad Astra.